Now that we know how valuable the forest is to meet our climate change goals, now we're going to hear from John Rogan. John is a professor at Clark University, Graduate School of Geography. His research collaborations have been with the USDA, the Department of Conservation and Recreation, the Worcester Tree Initiative, and Mass Audubon have resulted in policy relevant findings. He's done work on the impact of the Asian longhorn beetle on urban forest cover, the effectiveness of tree planting to reduce air temperatures in Massachusetts, environmental justice neighborhoods for the Greening the Gateway Cities program. And most recently, he's worked on the impact of solar field installations on forest cover and agricultural land in Massachusetts and Rhode Island. So John is going to make it very clear what some of the impacts of solar siting have had on our forests. John, it's all yours.
Thank you very much. Thank you for the introduction, and it's a great pleasure to be presenting today. And I'm presenting on behalf of myself and Sichi Tao, a PhD student at Clark University, and we welcome your feedback and comments. And I'll just start the presentation here now. So the title is Mapping Solar Installations in Massachusetts, looking at their direct ecological impact. And we use two types of data primarily. One type of data is satellite imagery, and it's called the Sentinel-2 sensor. It's a freely available source of data, and it has a revisit time, meaning it can collect a new image about every week. So it's a great source of data, and we use it frequently at Clark University. The other type of data we use is forest loss, and so we combine the satellite imagery in terms of detecting solar fields in Massachusetts and Rhode Island. We connect that to the forest loss information so that we can create estimates of the impact of new solar field development, or indeed past solar field development on forest resources. And so what you're going to hear from me in this brief presentation, it's going to be a lot of numbers, a lot of statistics, but we've done our best to try and boil things down into discrete, simplified information. And if you have any questions, of course, we can go into a lot of depth. But the time frame for this work, both in Massachusetts and Rhode Island, is the last 20 or so years. And today's presentation will focus mainly on Massachusetts, but I will speak about our work in Rhode Island. The reason I'm speaking more about Massachusetts today is because Sichi and I have just finished a long series of analyses that are brand new. Actually, they finished up about sometime yesterday. So, we're excited to share these with you. The issue here that we're dealing with, if you look at the image, is that we have a situation of any given forested area in the state and how it gets converted. And so the type of mapping we do and the information you'll see relates not only to the solar panels themselves, or we refer to them as solar installations, but also the area around those panels that have been cleared. So you see that for a panel to be installed, this may well be a new road. There's a certain easement that's created between the panels and the forest nearby. So the panels themselves are mapped, but also the what we call the cleared area is mapped also. And one more point of clarification is that in this image in the top right, in yellow, you're seeing panels that were detected, and around them, the area being cleared. And so we don't make any distinction between a company that owns certain types of panels or another. We refer to these installations, if you will, as groups or clusters of adjacent panels. Suffice to say, before I dive into the results here, I'm sparing a lot of detail. However, the method that we've developed at Clark allows for accurate, repeatable, timely updating of maps. And so we hope to take the results here and move into the summer, where we'll be making updated maps through 2021. So the first set of results allows us to contemplate the impact of solar installations, in this case, in the state of Massachusetts. The map that you see here on the right is not to scale. That is, the size of the solar installations are exaggerated for cartographic reasons. You'd all be having a heart attack otherwise. But that being said, there is widespread distribution of solar fields in Massachusetts, primarily in Worcester County, but other areas towards the Rhode Island border as well. And these maps and tools, if you will be available to anybody who'd like to take a look at them afterward. And Sichi has developed an online map that allows you to query this information. But we can look at some of these summary statistics to give you a taste of what the data can tell us. For one thing, there's 703 solar installations that have been installed since the time frame of the study. And that's about 6,850 acres. And when we add on to that the area cleared around solar, that amounts to 7,687 acres, or about 30% the size of the city of Worcester. So if you were to take all of the solar and cleared land and aggregate it into one space, it would be about a third the size of the city of Worcester. All told, when we add the land cleared for solar in Massachusetts and Rhode Island, it's over 8,000 acres, which is over half the size of the city of Providence, to give you a sense of scale there. Of course, it's not all aggregated together in that way, but it's dispersed throughout farmland and cleared land and forest land throughout both states, which has a very high degree of fragmentation. So you have these fragmenting features that are having basically untold ecological impacts at the moment. Some other points to make about the data: 44 solar installations have an array that's greater than 24 hectares. So as you see in this graph, in terms of the count of solar arrays and their distribution in terms of area, most arrays are in the smaller size, the size of 1 hectare, roughly the size of a football field, 2 football fields, 3 football fields, 4 football fields. So, you know, they're large in area, they're quite large in area, and they are distributed widely in various parts of the state. Some of them are on the much larger size, you know, 15 times the size of a football field. The median size of all solar installations is about 7 acres, which is quite large, right? So the median of the width of all of those fields from 1 to 15 acres is 7. So that's to give you a taste of the distribution of the fields and also their area as well. I mentioned that the tool that Sichi had designed. This is a tool that allows you to go online, and we can provide this information, and you can search by county or by town and query which areas have how many fields by comparison. In the case of this study, Worcester County has both the largest amount and the area of all of the solar installations in the state. And by town, the town of Palmer has the largest amount of solar installations at about 192 acres. So again, these data have been rendered from satellite through pretty complex techniques, but are available for you to use and query as you see fit. And indeed, if you see something else that you think should be included in an online mapping scenario, we'd be happy to talk about that. Okay, so we're focusing here on land that's influenced or impacted by solar in terms of what land cover was it prior to solar installation. And this pie chart here shows that for all of the land in Massachusetts, 49% of forest has gone to solar. 23% cropland to solar, and lowering amounts of grassland, barren, and others. And we take this information from available data sets, in this case, the USGS National Land Cover data. So all of our data sets are freely available and trustworthy information. On the y-axis here, you're seeing the hectares, or the area in solar from 2001 to 2019. And you can see as you go across the years that the green bar is the amount of forest loss, and the tan or brown bar is the surrounding cleared land. So you see that there's complementarity between the green and the brown in terms of how much total area is being impacted by solar development. And then we can trace it over time. We see that around 2010, 2011, solar development really picked up, most of it going to forest. And we see the uptick all the way through 2015, reaching its maximum in 2016, and then decreasing to the present day. So the data allow us to look at impacts by land cover, forest impact, and also tracing it over time as well. And we're developing these tools also for Rhode Island. We can start then to break down the data into some finer components. I just spoke about land cover. Here we've used the National Wetlands Inventory, and you're seeing here a map of national wetlands. That's the faded blue in the background. And then the X's are overlaps or adjacent solar fields. So this slide is talking about wetlands specifically, and where solar has been developed relative to those wetlands. So we've got some summary statistics for that. 57 solar sites overlap with wetlands, so that's a much smaller amount than the total, which is much larger. And the typical solar size, the typical solar installation size that overlaps with wetlands is around 10 acres. So a fairly large developments relative to, it's basically larger than the median for all solar. And the average distance to wetlands for all solar sites, so every solar site, is about 178 feet, which is within the range of nationally recognized buffer areas for wetlands and are recognized by all states. A summary statistic here will tell you that 32% of solar installations are at 100 feet or less, so they're well within that 100-foot buffer, and 54% are within the 200-foot buffer. So the summary of this slide is that there is a considerable amount of overlap and adjacency between solar field installations and wetlands that are recognized federally. We can then go into a more finer grain again. Here we identify those towns that actually have solar fields within that 100-feet buffer, or indeed solar fields that are actually in wetlands as defined by the National Wetlands Inventory. So again, just to reiterate, this is a far smaller subset of the total, but indeed we're identifying those towns that have solar that are within the wetlands themselves. In terms of the contributor, it's mostly forest. So in other words, forest loss or forest conversion to solar is the biggest contributor to those wetland overlaps. Okay, a couple more, and then I'll have a summary. We looked at three other instances. Natural heritage areas as identified by the state, and then rivers and ponds and lakes as well, just to give you a sense of the information. This is a map of the rare wildlife habitat in the state, and the X's indicate where solar fields are developed within those recognized habitats. And it's we can say here that on average, solar installations are about a half-mile overall from all nationally, or yes, all statewide rare wildlife habitats. So again, that overlap is rather pronounced in a lot of these sensitive areas. Here is a look at the proximity between solar development and lakes or ponds. The summary of this, again, the maps convey the X's where there are precise overlaps between them. And so the average distance from solar to lakes or ponds is about 1,200 feet. So they are much further away from those types of attributes when compared to wetlands, in that case, designated wetlands. And in terms of proximity to rivers, while ponds and lakes was about 1,200 feet, in this case, it's about 800 feet. So again, giving you a sense of that proximity and boiling down the numbers into something that's mappable and we can digest in this fairly simple way. Just a look to Rhode Island, we had a presentation last December and Scott was present at that, so he knows this story, but we also have conducted similar analysis for Rhode Island. We found that in the same time frame, there's 69 solar fields or solar arrays in Rhode Island, and that amounts to about 740 hectares of land impacted. And in terms of the land cover types that are impacted, 48.6 of that land is due to forest loss. So what we're seeing in both Massachusetts and Rhode Island is that forest loss is the single largest contributor to the development, or to allow the development of Rhode Island by far in both states. Work that will happen later in the month and in April will provide information on the wetland impacts and the natural heritage impacts as well. So in summary, this was a quick view, but hopefully helpful. We've mapped in Massachusetts 7,700 acres of land in solar installations. That's about the third the area of the city of Worcester. The median size of those arrays is 7 acres. And forest is impacted the most. About 50% of all land covers forests makes up 50% of the installations. In other words, 50% of all land occupied by solar has been due to deforestation. The quicker look we had at Rhode Island, which we'll follow up on soon, is that there are 69 installations at 740 acres, and 48% of forest loss went into the total amount of loss. In terms of wetlands and solar installations overlap, it's considerable. 32% of installations are within 100 feet of wetlands, the 100-foot buffer, and the average proximity is less than 200 feet. We've presented here today what we feel is an accurate, repeatable approach using freely available satellite data. And CICI has developed an online tool that allows data viewing by county or town. And the next steps will be to complete the Rhode Island analysis and update both states for 2021. And the single statistic I'll leave you is that the total land area in Massachusetts and Rhode Island is 8,440 acres, well over half the size of the city of Providence, about 60% the size of Providence. And just acknowledge many of the people who work very hard on this, the Clark University Human Environment Regional Observatory team, our HERO program, Emily and Max who worked on the solar information, and special thanks to Heidi, Stephanie, Martha, and Zara who have provided lots and lots of advice and information along the way. If you'd like to reach out to find out more, my information is here. And thank you very much.